So Monday, quiz. Some things I wanted to point out. I told you I wanted to revisit density, talk about that a little bit more. Understanding that the density is the same for all of the same substances. So it doesn't matter what the shape is or what it is. If it's made out of the same substance, it's the same density. Okay? So for example, all aluminum is 2.70 grams per cubic centimeter. Whether it's regular aluminum foil, whether it's heavy-duty aluminum foil, 2.70 grams per cubic centimeter, or grams per milliliter, same thing. If it was an aluminum, little aluminum cube, it'd still have a density of 2.70 grams per cubic centimeter. You should also be able to know the formulas, density equals mass over volume, understanding what mass is, how we find mass, what volume is, how we find volume. We find volume a couple different ways. We can do it with displacement in a graduated cylinder. We could also do it with this formula where volume equals length times width times height, right? You should also be able to rearrange these formulas so that we could solve for a different variable. And so the way we do that is by, first of all, making sure that the variable we're solving for is on the top part of the equation. And if there's no bottom part of the equation, that means everything's on the top part of the equation. And also making sure that variable is by itself. So for example, if I wanted to switch this volume one, volume equals length times width times height, to solve for, say, height, then what I would do is try to get rid of this length times width part. So I would take it to the other side of the equal sign. And the rule is if it's on the top, on one side of the equal sign, and I move it across, then it's got to go on the bottom. If it was on the bottom on one side of the equal sign, and I move it across, it goes up on top. And everything is multiply or divide. All right, so if I want height by itself, because I want to solve for height, I'm just going to take this over here to the other side. I'm going to put it down here, length times width down there. Now it's gone from here, and now I could solve for height. If I rearrange the density one to solve for volume, take volume to the left, which puts it on top. Take density to the right, which puts it on the bottom, and I end up with volume equals mass divided by density. That was how we were supposed to work that relationship to find the thickness of the aluminum foil. Of course, our models need to be able to make models always. We need to be able to show things like particles moving using arrows. We need to be able to show different speeds of particles moving with arrows. How do we show it with different arrows? Of course, we want to pay attention to conservation of matter in our models. And then something that came up from food dye when we were talking was talking about the speed of the particles. So you guys said in hot water, particles move faster. They move faster, and as we discussed it, it kind of came out these terms, energy and collisions. And so when particles move faster, they move faster because they have more energy. And since they're moving faster, there's going to be more collisions. Collisions with other particles, other water particles, other food dye particles, for example, with food dye, making it spread out. Cooler is going to have less energy, and because it has less energy, not moving as quickly, there's going to be less collisions. But those are the main ideas. Anything we've been talking about this past week is fair game, but this is kind of a good refresher outline for what is on your quiz.